Hey guys, it's Miss Richardson. I hope you're doing well. I just wanted to make you a video over your lessons on functions this week. So functions are so fun. That's why it starts with an F-U-N. I just came up with that. All right, so let's look at a few problems, all right? So the definition of functions, well, in my words, I'm sure there's a more scientific definition of functions, but for every input, there's exactly one output, okay? For every input value, there's only one output value, okay? So input values are X in a set of ordered pairs, and output values are Y in a set of ordered pairs. So look at, I'm trying to find my pen. There it is. So if you look at the X values, I have a 0, 1, 5, 6, 7. So all of my output values, whatever they are, they have exactly one input value. In other words, the input value of 0 only goes with the output value of 1. Now, if I added one more ordered pair and I said when X is 0, Y is 3, I would say this is not a function because the input value of 0 has 2 output values. But the way it's written, this is a function. Now, if you are thinking about, well, there's 3 7s. Well, it doesn't matter what the Y values are. As long as none of your X values repeat, this is a function. This is a function, okay? So look at this table. We have all these input values, -2, -1, 0, 1, 2, and all of these have exactly one output value. So this table represents a function. And then we have, this is called a mapping. And we have input value of A. A goes with the letter X. The input value of B has exactly one output value. The input value of C has exactly one output value. And the input value of D has exactly one output value. So this is a function. All right, so if you look at this table right here, well, this is a graph actually. I could come up with ordered pairs for each of these points. So this ordered, if I start at the origin and go right 6, up 6, this ordered pair is 6, 6. This ordered pair is +3, +3. This point right here is -4, 3, -4, 3. And this point here is -4, -3. All right, I can stop right there because I have two different output values for the input value of Y. So this is not a function because there can only be one output value for every input value. And here we have two different output values for the input value of -4. This graph is not a function. All right, let's go, we'll do this in just a second, but let's go to this graph right here, or this table, I should say. All right, so do you see the input value of 9 has an output of 3 and -3? So since the X values repeat, this is not a function. Now, if I want to find out if this is a function, I can look at my table, and I already kind of have a feeling it's a function because none of the X values repeat. But just to double check, I can make sure each of those input values have one output value. So I can plug in -2 for X. So if X were -2, what's -2 squared? What's -2 times -2? +4. So it would be 4 minus 5 times -2 plus 4. So that would be 4 plus 10 plus 4 is 18. I could square -1. -1 squared is 1. And 1 minus 5 times -1 is actually +5 plus 4. So that would be 9, 10. Anything times 0 is 0. So 0 squared is 0 minus 0 plus 4. And then I could plug in 1. 1 squared is 1. 1 plus 5 is 6. And 6 plus 4 is 10. 18, and I don't know what 3 is, but I'm not taking the time to do that because we know at this point that every input value has exactly one output value, so that is a function. All right, so one of the things that you have to do in your lessons is find the rate of change. So we can do that on a table, on an equation, and on a graph like these. So what you want to do is look for two ordered pairs. So this specific ordered pair is 0, 4. So I'm going to try to make a dot, even though this pen hates dots. Now, -2, this is not an exact coordinate. It doesn't go right through this corner. So I'm going to use this point right here and this point right here. My pen hates those little circles. All right, so what you're going to do is you're going to create a right triangle. You're going to find 2 points, and you're going to make a right triangle, and you're going to write the ratio of how tall, or the rise over the run. So how tall over how wide. So how tall is this right triangle? It's 2 units tall and 1 unit wide. So the rate of change is 2 over 1, which is 2. So the rate of change is 2. And we could have done that anywhere we see an exact coordinate, like here and here. Once again, it'd be 2 over 1. All right, let's look at this one. So I already have dots on this one, so let's just make our right triangle. Pretend I can make a straight line. So what is our rise? How tall is this triangle? 1 unit. How wide is it? What's the run? 1. So the rise is 1, the run is 1, 1 divided by 1 is 1. So the rate of change is 1. This rate of change was 2. All right, what about this? All these little dots, we could use any of these triangles. We could even do a big old triangle, right? Look at that. What would be the height? 1, 2, 3 over 1, 2, 3. Well, guess what 3 divided by 3 is? 1. So the rate of change on this one is also 1. And if we did any of these little bitty triangles, we would still get 1 over 1. Let's look at this, this one down here. This is an exact coordinate, 3, 3. Do you see that? That's an exact coordinate at 3, 3. And then the next one is here at 0, 1. Well, if I make my right triangle, how tall is this? 2. And what is the run? 1, 2, 3. So the rate of change is 2 over 3. So 0.66666. The rate of change is 2 over 3. Now make sure you don't put 3 over 2. You have to do the rise on top and the run on the bottom. All right, here we got some points. So let's make our right triangle. Now, if you notice all of these lines on this whole page go up and to the right. So all of these have positive rates of change. And this one has a negative rate of change, but it still tells us about how steep our line is, which is fine, but we're going to do our rise. So 1, 2, 3, 4 over 1, 2, 3, 4, 5. So rise over run. So our rate of change, also called our slope, is 4/5. But since it's a negative, since it's going down and to the right, it's a negative slope. But it's still steeper, 0.8. Even if it's negative 0.8, it's still steeper than 2/3, 0.666. So if it asked of these two right here, which of these two had a greater rate of change, even though this is a negative number, this one has a greater rate of change. Okay. All right, what about the last one? We're going to do our triangle. What's our rise? 1, 2, 3. What's our run? 1, 2, 3, 4. So our rise is 3, our run is 4. So this is 0.75. So this would be 0.75, 0.8 or negative 0.8, and 0.66666. So this one's still the biggest rate of change. This is in second place if we were comparing these three down here, and this is in third place. Of course, we didn't talk about the ones on the top as much, but that's how you find the rate of change on a graph. You find two exact points, You make your right triangle and then you count rise over run. And it wouldn't matter if I did my triangle up here above the line, that would be fine as well. Just make sure you count rise first, up and down first, so it's still 4 over 5, 4 over 5. All right, now we're gonna move on. So just a note that you'll need to remember forever and ever and ever. I was just teaching this in college just a month ago. Horizontal lines have a rate of change of 0. So the rate of change of any horizontal line, like that purple one, the horizon, if you look out the horizon, you're looking this way, right? The rate of change of all horizontal lines is 0. The rate of change of horizontal lines is 0. All right, so now we have 1, 2, 3, 4, 5 tables. You can find the rate of change on tables as well. So the rate of change is your change in Y over your change in X. Okay, so let's see what that means. So our change in Y, so what is happening in the Y column? What are these numbers doing? These are increasing by 1, plus 1, plus 1, plus 1. And what is happening in our X column? What are these numbers doing? They are increasing by plus 1, plus 1, plus 1. So our change in Y is 1, our change in X is 1, and that means our rate of change is 1 divided by 1, which is 1. All right, let's look at the next one. We're going to do our change in Y. What's happening in my Y column? Plus 4, plus 4, plus 4. Our change in X is plus 1, plus 1, plus 1. So our change in Y over our change in X is 4 over 1, which is 4. So our rate of change is 4. Now, they don't have to the X's don't have to increase by, well, let's do this one first. All right, so the X's are increasing by 1. And what's happening to the Y column? It's increasing by 3, So we always put change in Y first over change in X. So 3 divided by 1 is 3. So like I was about to say, the X doesn't always have to increase by 1 like the rest of these. We're still going to find the rate of change the same way. So this is going to be doing what? What's happening here? What are these numbers doing? How do you go from -4 to +2? You add 6, you guys. You add 6. How do you go from 2 to 4? You add 2. And how do you go from 4 to 6? You add 2. So this is making me think, because of the first term here, this is making me think this is not a linear function. All right, so we want to see if it's consistent. So from -2 to 0, how do you get from -2 to 0? You add 2. How do you get from 0 to 2? You add 2. And from 2 to 4, you add 2. All right, so see what happened here? This change in X is consistent, but the change in Y is not consistent. So this is not linear. This is not linear. Boop, not linear. Okay. Now look at the last one. So what has happened in our Y column? We're adding 5. We're adding 5, and we're adding 5. And then what's happening in our X column? We're adding 2, adding 2, adding 2. So we're consistent, first of all. So it's definitely a function, right? And now we want to know, what is our change in Y? It's 5 over, what is our change in X? It's 2. So our change in Y is 5 over 2, or 5 halves. Or you could even say it's 2.5 or 2.5. Okay, so the rate of change is 5 over 2, 5 halves. Now, if you have an equation, this is the easiest way to find the rate of change. The rate of change is the number being multiplied by the variable X. The rate of change is the number being multiplied by, it's supposed to be an I, the variable by x. So what is the rate of change in this first equation? What number is being multiplied by x? 4. What is the rate of change in this equation? 1/2. Or I could say 0.5. Either way. What is the rate of change in this equation? 5. What is the rate of change in this equation? What number is being multiplied by x? -2. Oh, and let me write one more and add it to your paper too. What if I give you y equals x? What is the rate of change? You might want to say the rate of change is 0, but it's not, because 0 times x isn't x, it's 0. What would I multiply x by to get x? 1. Isn't 1 times x, x? So the rate of change in this equation right here is 1, because 1 times x is x. All right, let's look at the problem on the bottom of the page here. It says, compare these functions, which has the greater rate of change. So I could pick any point. It looks like all of these go straight through a coordinate. This goes through a coordinate. Oh, my pen hates little dots. I don't know why. So I'm going to use these two. It doesn't matter. If I make my triangle, how tall is it and how wide is it? 1/1. So the rate of change is 1. Actually, it's going down and to the right. So it's actually -1. That's okay. What's the rate of change of the equation? The rate of change is 1/2 or 0.5. And the question is, which one has the greater rate of change? So I know that a -1 is less than a positive 1/2, but the rate of change, it's for if you're doing a rate of change, and even if it's a negative, you pretty much ignore the negative and say, okay, which is bigger? Or you could think, what's the absolute value of -1? 1, and 1 is greater than 1/2. So this has a greater rate of change. If it were positive 1 or -1, it's going to be greater than a bigger rate of change than 1/2. All right, so let's look at these 3 types of problems. We have all 3 things. We have an equation, we have a graph, and we have a table. So it says fill in the value of each function. So here's an equation. What happens to y when x is equal to 3? So our equation is y equals -4 times x plus 2. Well, it's telling us to substitute 3 for x. So what is y when x is 3? Well, let's find out. -4 times 3 is -12, and -12 plus 2 is -10. So when x is 3, y is -10. All right, here's our graph. When x is 3, well, remember, if it's labeled for you here. This is our y-axis. So here x is -3, here x is -2, here x is -1. So when x is 3, here's x is 3, it wants to know what's the y value. Well, there's a point right there. What is that ordered pair? It's 3, not -3. 3, -1. So when x is 3, y is -1. That's the answer. And then our input output, when we have an input of 3, right here, when the input is 3, what is the output? The answer is -3. All right, the next one is basically giving us 2 graphs, or a graph and an equation. It says, after 15 months, which function will have Brian paying the most money? Well, our months of membership is on the bottom. So at 15 months, how much money will Brian pay? So at 15 months, Brian will pay $100 using this function. Down here, it's saying that he's going to pay $22 a month, every month, plus $9.50 per, or I guess this may be a year, I don't know. He has a fee, so this is the fee that doesn't change, plus he has to pay $9.50 per month, okay? Well, the number of months is 15. So I guess every month he's paid $9.50 more. All right, so if I plug in 15 there, I'm going to, in my calculator, I'm doing 9.5 times 15 plus 22, and I'm showing that Brian will pay $164.50. So function on the graph or the equation, will Brian pay more? Well, Brian's going to pay more here. Okay, so at first he would probably pay less. For 5 months, he'd probably pay less for this graph, but eventually he's going to pay more with the equation. All right, so the next question says, which ordered, it should say ordered pairs, excuse me, you guys, which ordered pairs go with the function? I don't know. Well, 2 of them start with 1 and 2 of them start with 0. So let's start with 0, or let's start with 1 and see if we can eliminate either one of these. Well, we got to eliminate one of them, right? So when x is 1, uh-oh, look, I messed up there too. That should be 8x minus 2. I'm going to try to change that before I send it to you if I can remember. All right, so 8 times 1 is 8, and 8 minus 2 is 6. So y is 6 when x is 1. So guess what we did? We eliminated that one. We haven't eliminated this one yet. All right, so, and then look, this says 1, 6 also. So these are both in agreement so far. Now, these disagree on 2. So let's see what happens when we plug in 2 for x. Well, 8 times 2 is 16, and 16 minus 2 is 14. So that one's gone, right? So this one's still in the picture. Now let's see. Oh yeah, that one said 13 also, didn't it? All right, so there's only one left, and if we plugged in 0, anything times 0 is 0, and 0 minus 2 is -2, so that one's right. Now let's look at the next one. It says the graph represents function 1 and the equation represents function 2. Function 1, we have a horizontal graph, a horizontal line, and what I tell you is the rate of change of horizontal lines. The rate of change is going to be 0. What is the rate of change of function 2? What's being multiplied by x? The rate of change is 2. The question is how much more? What does that mean in math, how much more? It means subtraction, right? How much more is the rate of change of function 2? We're going to subtract the rate of change of function 2 minus the rate of change of function 1, and the answer is 2. The rate of change is 2 more in function 2 than function 1. All right, so linear equations are functions either way. You see the word line in there? Linear. Basically, any linear equation or linear function, when you graph it, it forms a straight line, okay? When you have a linear function, it's always in the order, it almost always, not always, but almost always has an x and a y. And the way you can tell it's linear is if the exponents are only ones. So 5 to the first power is 5, right? So I wouldn't actually see the exponent written. I wouldn't see 5 to the first power is 5. I would just know that it's there. So do you see any exponents here? Nope. That means that this is linear because it's y to the first power is equal to 4 times x to the first power plus 4. Clearly, this exponent is greater than 1. So this is not a linear function. And here the exponent is the variable is the exponent. So this is not a linear function. So if you have an x and y raised to the first power, you know that's a linear equation. Now this is a function. It is a function. If we graphed it, we'd have one y value for every x value, but it's not a linear function. Linear means specifically it makes a straight line when we graph it. All right, so one thing about a linear function, remember on that other slide when I said, oh, these aren't consistent, it's not linear. For linear functions, the change in y over the change in x has to be consistent. It doesn't mean it has to go up by 1, but if, I'll show you in a few minutes what I'm talking about. All right, so here the change in x is plus 2. And here the change in y is -3. And if we want to continue with that pattern, make sure this is function, what will this x input and output value be? Well, if we're adding 2, this is going to be 7. And if we're subtracting 3, this is going to be 4. So those values are going to make sure that this stays a linear function. Now, the graphs are so easy to determine, right? Because you can tell quickly whether it forms a straight line or not. Is this a straight line? No. Is this a straight line? No. Is the purple one a straight line? No. This is clearly a linear function because it has been graphed and it makes a straight line. All right, tell whether this is linear or not. All right, so let's look right here. So our x is increasing by 1, by 1, by 1, by 1, by 1, by 1. So that's consistent. Here we have an increase of 1, but look, we have an increase of 2, we have an increase of 12, right? So this is not linear. Not linear. I could say the rate of change. The rate of change. The rate of change changes. That's why it's not linear. The rate of change is not consistent. That's a better way of saying it. The rate of change is not consistent. Now, if you had, let's say we have 0, 1, and then the 2, and then 4. And let's say we had this. All right, so my rate of, my change in x is plus 1, plus 1, plus 2, right? And here my change in y is plus 3, and plus 6. So is this linear? It is, because it's about the rate of change. The rate of change is the change in y over the change in x. So we have 3 over 1, 3 over 1. And then here, wouldn't this be 6 over 2? And isn't 3 divided by 1, 3? And isn't 6 divided by 2, 3? So these numbers don't have to increase consistently, but the ratio of change in y over x has to be the same. See what I'm saying? So I don't want you to think just because the x changes and it doesn't increase by 1, automatically it's not linear. Well, we're not sure. We have to figure out the change in y over the change in x, okay? I'm gonna erase this, so what a mess. All right, so the next one is saying, is this a linear function? Well, yes, because the x and y both have the exponent of 1. The x and y variables have an exponent of 1. Also, I can graph it and prove that it's linear. So first of all, let's answer this question again. Why is this not linear? Because the rate of change is not consistent. Write that on your paper. The rate of change is not consistent. This one is linear. One of the answers could be the x and y both have exponents of 1. Coffee break. Now let's go ahead and graph it and double check and make sure it makes a straight line. What if x is 0? Anything times 0 is 0, and 0 plus 1 is 1. What if x is 1? 2 times 1 is 2, and 2 plus 1 is 3. 2 times 2, if x is 2, 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, and 6 plus 1 is 7. And then 4 times 2 is 8, plus 1 is 9. All right, so let's graph these. These are like ordered pairs right here. 0, 1. Don't go right or left, go up 1. That's the first point. All right, go 1, 3. So go right 1, up 3. 1, 2, 3. 2, 5. We're going to go from the origin, right 2, up 5. 1, 2, 3, 4, 5. 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And then I'm out of space. But if I had a ruler, I could pretend I'm going to make the straightest line you've ever seen. I'm so bad about this, but guys, I'm doing pretty good. Woo, look at that. All right, so is this a linear equation? We've already said it is because the x and y had exponents of 1. The other good reason is when I graphed it, it made a straight line. When I graphed the equation, it formed a straight line. How about that? Jessica has $1,000 in the bank. She earns $250 every month working her part-time job. Write an equation of how much money Jessica will have after X months. Let her total be Y. Her total is going to be $250 per month I don't know how many months, so we're going to multiply 250 times X, plus she started out with $1,000. Now it wants us to graph it. So clearly, since Jessica is starting out with $1,000, we're going to count this probably by, let's say what? I don't know. Let's do 500, 1,000, 1,500, 2,000, 2,500, 3,000, so on and so forth, okay? So what are these things here on the bottom? These are going to be months, right? So 0 months, come on. Let's do 1 month, we'll spread it out. We don't have to have the months right on top of each other. 4 months, 5 months, 6 months. All right, so for all graphs, make sure you tell me what these numbers are. Well, these numbers are months. And what is this? This is her total. All right, so the question is, so we're going to graph it, but the first question is, what is Jessica's initial value? Well, at 0 months, if I plugged a 0 in right here, 250 times 0 is 0, but 0 plus 1,000 is 1,000. So she started out with $1,000. That is her initial. So at 0, when X is 0, that, whatever the Y value is, X is 0, whatever the Y value is, that is the initial, what she started out with. All right, after 1 month, so 250 times 1 is 250, and 250 plus 100 is 1,250. So if that's 1,500, that's 1,000. After 1 month, she would have this much money, right? 1,250. And then the next month, she'd have $500 plus 1,000, which is $1,500. And then she's going to have 250 more, 250 more, 250 more. Oh, I'm putting them way too close. Ah, whoopsie. I forgot that I skipped. Can I erase that? No, I guess I can't. All right. Did you guys do it right on your paper? I hope y'all are going along with me now. All right, so after 3 months, she would have, what, here? Yeah. And then 4 months, she would have 2,000. Oh my goodness. Anyway, so that's definitely linear, isn't it? It's definitely linear, and it would go in that position forever. She could work forever, for all of eternity. So then what is her rate of change? So first of all, the initial, when X is 0, Y is 1,000. That's what she started out with. And then it asks, what's her rate of change? Well, what is it? What's being multiplied by the X? $250. All right, what could this graph show? So pretend that we're still talking about money. Well, they're both, I guess it's talking about money. The first table says dollars. So let's think of a scenario that could happen here, right? All right, so what could this graph show? This could show that, I don't know, Dave started out with, how much money did he start out with? Well, after day 0, he already had $350. And he added how much per day? Well, this is going up by 100, but this is going up by 2 days. So how much did he add per day? He added $50 per day. So my total would be $50 per day plus $350. So after 6 days, let's make sure this is right. Let's make sure we're right. So after 6 days, he'd have $300 because 50 times 6 is 300, and 300 plus 350 is 650. So that is right. If I wrote $100 times X plus 350, that would not be correct because he's not earning $100 a day. He's earning $100 every 2 days, which is $50 a day. All right, what could this graph show? Well, Dave is adding to his money, isn't he? Dave's money is increasing, but if I had at 0 days, I had $1,700, And after day 1, I would say negative 14 times 1 is negative 14. And negative 14 plus 1,700 is 16. What? Help me out, smart kids. 86? I think so. So this person's not adding money. This person is actually what? If you're not adding money, you are probably spending money. So I would say Jack starts out with $1,700 and spends $14 per day or month or whatever it is. Okay, so those are scenarios that could go with that information. All right, based on this graph, what is the initial value? So remember what I told you, when X is 0, Y is the initial. Y is the initial value. Oh my goodness, I write so horribly. So when X is 0, right here, when X is 0, what is Y? Y is negative 2. So what is the initial value? The answer is negative 2. The initial value is negative 2 because that's where it's, even though it looks like it starts way down here, when X is 0, Y is negative 2. All right, let's look at a couple of graphs. We're almost done. All right, so these are like distance time graphs. So one thing that you need to think about as far as time goes is time is always increasing. So anytime you have time distance graphs, the x-axis has to be time because it's always going to be increasing. And you can't stop time or make time go backwards. So the first question says, which interval on the graph could be described as linear increasing? All right, if you know how we read from left to right, if I said, what is this word? You would read this word love because you read from left to right. If there was no rule on how to read, we would say this word is evol, because we're reading it from right to left. I hope some of you are laughing because I feel stupid saying evil. So you always read graphs from left to right. So from left to right, this line is going down. And then all of a sudden, what does it do? It increases. This is staying consistently flat. This is not increasing or decreasing. It's staying consistent. And then my line goes down again. So what part is increasing? The answer is B. All right, which of the following best describes interval C on the graph? Oh, obviously I took your choices out. But C is a part of the graph that's not increasing or decreasing. So I don't know what the scenario was. I should have snipped that a little better. Excuse me. All right, so the graph shown here represents Tommy's drive to work as a function of his distance from home over time. So our time is increasing, and then you always have to look at what the y-axis is measuring. It's measuring the distance from home. So if he is 0 miles from home, what does that mean? That means he is home. He is at home. So as time increases, so we're going this way on our graph, as time is increasing, he is getting farther away from his home, right? Part B, he's still getting farther away from home. In fact, he's getting farther away from home on almost the entire graph, but on part B, he's going faster than he was in part A. His rate of change is increased. So he's still going away from home, but he's going away from home faster, at a faster rate. And then what happens at C right here? And that's the question. What description could best explain what is happening during Tommy's drive? So Tommy left his home at C. He already left his home. He left his home at part A. Tommy got to work? Well, maybe, but since in a few minutes he continued on farther from home, he probably got to work right there, right? Because this is a 4-minute span, not even 4 minutes, 3 minutes. This is a 3-minute span from 10 minutes to 13 minutes. He's not increasing his distance or decreasing his distance. Tommy drove the speed limit. Well, he's not getting further from home, so that can't be right. He waited at a red light. That makes sense because time is still increasing. Time is going from 10 minutes to 13 minutes. but his distance isn't changing. So that makes D the best answer. All right, Jamie rode her bike for 5 blocks before realizing. So she's on her bike, right? She's driving her bike, riding her bike. She left school, and then she realizes, I forgot my math book and I have to get it. So she turns her bike around immediately, goes back to school, looks for her book, finds it, and then rides home. So which of these graphs matches this scenario? And once again, this is distance from home. So 3 of these shows that her journey starts out far from home, right? She's 8 blocks from home here. She's 9 blocks from home here. She's 8 blocks from home. I don't know why these are inconsistent, but it doesn't say, I can't see. Is that supposed to be a 9? Anyway, I marked it off. So if that's a 9, we already know what our answer is, don't we? But I can't see it. But obviously this one is not the right answer because she starts off at home here, but according to our scenario, she's at school. So let's go ahead and mark this one off. So let's pretend that we think the answer is either B, C, or D. So if she's going from school closer to her home, and if she forgets, she forgets her book, and then what does she do here? She stops. She stops for 4 minutes. Does it say that she stopped and then realized she forgot her book? It doesn't say that. She was just thinking and it's like, oh no, I forgot my book, I gotta turn around. Now, when she turns around, what does she do then? She has to go back to school. So wouldn't she go back to where she started? So this graph and this graph shows that she goes back to where she started. Here, she's 8 minutes from home. She stops here, turns around immediately and goes back to where she started. And then she's there for a while. This one, when she gets back to the school, she doesn't stop. She goes immediately, turns around and goes home. So it can't be this one because she never makes it back to school in this one. So the reason that this is the best answer is because she realizes she forgets her book, turns around, goes right back to school, and then it takes her time to find the book. She's not increasing or decreasing her distance from home, but her time is continuing, and she's at the school looking for a book, and then she comes home. So D is the best answer. All right, so that was a lot of information. But anyway, I hope that helped. And as you get through the whole week with your functions, on Monday you'll have your practice test, which is a lot like your test. Next Tuesday we'll Zoom, and then your test will be next Wednesday. All right, you guys, if you need me, let me know.